So just like yesterday, our learning target for the day was identifying the scaled copy and then identifying our scale factor. So what we're going to be utilizing here is how to find a scale factor. At the top of your paper, what I want you guys to go ahead and write down is just a quick idea or a quick way to find the scale factor. If you are given an original image, we'll call it the old, and then you're given a scaled copy, which we'll call like the new, you would just have to divide. You take new divided by old. That's all you're going to be doing. Those of you with your computers open, go ahead and close. Thank you. So up at the top, I want you to write down the following. To find your scale factor, in order to find your scale factor, all you're going to do is you're going to take your, and I'll write this in parentheses, we're going to write our new, which is called our scaled drawing. So it's kind of like our new, and we're going to divide it, that's our mathematical operation, we're going to divide it by what we call the old, which was your original drawing. That will provide to you what your scale factor is. You're taking your newest and you're dividing it by your oldest. Now notice that when we're talking about shapes, shapes have multiple sides to them. So you can't just pick any side and divide it by another. You have to make sure that the side is corresponding. That means that they align. They're similar to each other. Okay? So for example here, in my original, my sides are 3 is my bottom base, 4 is my height base, and then 5 represents what we call a hypotenuse. The reason it's a hypotenuse is because this is a right triangle, but it's basically the third side of my triangle. Now, A. Would you say A is a scaled copy? The first thing I need to look at, is it also a right triangle? Is this a right triangle? No, this is not a right triangle. So is this a copy of my original? No. To be a copy, it has to be identical in its shape. Must keep the same shape. It cannot slant. It cannot change that characteristic of being a right triangle. Okay, it has to be the same. So this right off the bat, we know is not going to be a scaled copy because it's not a right triangle like the original. So we're going to go ahead and cross that off. That one's not going to work. Now for problem B, is this a scaled copy?
Yes.
Yeah, it is. Yes, sir. It is a scaled copy. Now the sides that are going to match up. So remember, I'm going to go ahead and use my colors. I've got this measurement. I'm going to go ahead and highlight in blue, and it's going to match up with this side. That will be in my blue. I've got my height. I'm going to go ahead and highlight it in my pink, and this height is going to highlight in my pink. And then we've got our hypotenuse. Like I said, the hypotenuse, I'm going to highlight that 5 in green and highlight this one in green. Yeah, if you guys need your colors, you know that your star table has your colors. So we identified that shape B. Where's my purple? There's my purple. We identified that shape B is a scale to it. The sides that match up, the 3 happens to match up with this 3, with the original 3. The 4 on my scaled copy matches up with the 4 on my original. And the 5 on my scale matches up with the 5 on my original. So what's my scale factor? If I take 3 and divide it by 3, what do I get? 1. If I take 4 and divide it by 4, what do I get? 1. If I take 5 and divide it by 5, what do I get? 1. So that means my scale factor is 1. Okay, we're going to go ahead and check problem C. We're going to see if problem C would be a scaled copy Do you think, by the look of it, does it look like it would be a scaled copy?
No.
No, doesn't look like it, but we'll double check. If I take my 2 and divide it by 3, I'm going to get 0.6 repeated. And then if I take 5 and divide it by 4, I'm going to get 1.25. Those are not the same, right? They are not the same for scale factor. In order for it to be a scaled copy, that scale factor has to be the same throughout the entire problem. So this is not going to be a scaled copy. I can go ahead and cross that one off. All right, from the looks of it, for problem D, does problem D look like it potentially or possibly could be a scaled copy? Yeah, it looks like it could be. Let's go ahead and we're going to double check. So I'm not sure. I'm going to put a little question mark by it right now, but I'm going to go ahead and write D in here, and we're going to check to see if it is. Now, here's what will match up. I have 3/2 that I'm going to put here. On this side, I have a 2 for the height. So I'm going to map it up as the height in my table here. And then the hypotenuse was 5/2. So I'm going to map it up here, 5/2. And remember, we're going to take the new picture and we're going to divide it by the old, which was in my gray. So I'm going to take D, triangle D, and I'm going to divide it by triangle O. So we're going to take 3/2. So I'm going to use my little calculator here. Everybody can see the calculator on the screen?
Yes.
We're going to take 3/2, and we're going to divide it by what? What am I going to divide it by? 3, because the original value was 3. So we're going to divide it by 3, and that becomes 1/2. Okay, so now we're going to do the same thing here. We're going to take 2, and we're going to divide it by what? 4. So I'm going to do 2, and I'm going to divide it by 4, and that comes out to 1/2, or 0.5. If you did 2 divided by 4, you'd get 0.5, but as a fraction, it's 1/2. Then I'm going to do the same thing here. I'm going to take 5/2, and I'm going to divide it by what? What was the original? 5. So we're going to take 5/2, and we're going to divide it by 5, and we get 1/2. So we got the same thing throughout. So is it a scaled copy? Yes. It is a scaled copy, and it's going to be 1/2 is my scale. Okay, let's take a look at E. Do you think E potentially could be a scale? All right, well then let's check it. Let's go ahead and put E down. What I want you guys to do is you're going to write down which dimensions belong in here, and you're going to tell me what was the scale factor that you found. So you guys finished filling this in. You should have mapped these up. We should say that the 6 was going to be the one that maps up with the 3. So we're going to put 6 in our first measurement, and then the 8 mapped up with the with the 4.
And then the 10 matched up with the 5.
Very good. The 10 matched up with the 5. All right. So when we divide, remember you always take the new value. So we're taking 6 and we're going to divide it by the original. So we're going to do 6 divided by 3. We're going to do the 4 divided by, ooh, I accidentally put a 4 here instead of an 8. Woo! Y'all didn't catch that. You didn't catch it. Okay. 8 divided by the 4. Oh, you didn't want to embarrass me? 10 divided by the 5. And so all of them come out to 2. So our scale factor is 2. You okay there? She's struggling. All right. What about F? Does F look like it's going to be a scale? Why not?
It's just it's too triangle-like. It's too
normal.
What do you mean? Thank you.
It's like a little
Quiet.
special, but it's not that special.
Okay. Kyla, can you give us the correct response?
It's not a right triangle.
It's not a right triangle. Remember, they're all triangles. Remember, you're being videoed.
We're being videoed?
Yeah.
Hi, camera.
Okay. So, Remember, in order for it to be a scale, it has to make sure that it's the same type of shape. If this is a right triangle, it has to be a right triangle. So this one is definitely not worth our testing at all. Okay, so now we have to decide between G and H. Which one do you think it's going to be, G or H? G. Because look at H. H has, if we look at H, the base and the height are identical. Were the base and the height identical on our first one? No. So the base and the height being identical means it's not going to be the same scale factor throughout. Automatically, this is what throws it off and makes it not a value to work. So we can cross this off. Let's go ahead and find the scale factor for G. So again, the 2 is going to be placed inside of the first box. The 8/3 is going to go into our next box. And then the 10/3 is going to go into our last box. And we are going to divide. So we're going to do 2 divided by 3. We're going to keep it in fraction form, though. Keep it in fraction form. It's what? 2/3. 2/3. Then we're going to do 8/3, and we're going to divide it by 4. That's also going to come out to 2/3. We'll do 10/3 and divide it by 5. That will also come out to 2/3. Okay, so our fraction value is 2/3. Notice, let's look back at the picture. Notice that when our scale factor was a 1, did the size change? No. When the scale factor was less than 1, so triangle D and triangle G, when it was less than 1, the triangle got smaller. And when the scale factor was bigger than 1, the triangle got larger, bigger.
Yeah, because yesterday you said that.
Yep, yesterday we talked about that if your scale factor is greater than 1, it's going to increase or enlarge your scale. If your scale factor is less than 1, it's going to reduce the size. Okay, so let's take a look here at these pictures. The large robot, this large robot below is a scaled copy of the small robot. So that means the small robot is the original. The big robot is the scaled copy. It's the enlargement. Okay, because each side length is multiplied by itself. That's what they're saying. They're saying that we're going to do 3 times 3, we're going to do 4 times 4, and we're going to do 1 times 1. Is that going to make this a true scaled copy? Yes or no? Talk about it amongst your group. Remember what we talked about with scale copies and a scale factor. Is this small robot and this big robot going to be, so is the big robot a true scaled copy? You're going to identify whether that's true or false, and then you're going to discuss with your group why you think it is true or why you think it is false. Go ahead and take a moment to do that.
Thanks for giving us.
All right, so is this a true statement or a false statement? False. This is false. Okay, here's the problem. Remember, in order for it to be a scaled copy, the scale factor has to be the same throughout the whole problem. But when we're looking here, this measurement was a 3 and this is a 9. If I do 9 divided by 3, I'm going to get 3. But then when I look at the next measurement, here I've got 4, and it's supposed to become a 16. If I do 16 divided by 4, that becomes a 4. These are not equal. They are not the same scale factor. So this is not a true copy. In order for it to be a true copy, it has to have a scale factor that is the same throughout the entire problem. Must be the same throughout the entire problem. Okay, go ahead and flip it on over to the back. And you guys, as a group, you are going to identify whether the problem that they're discussing is a true statement or a false statement and justify why. As a group. Go ahead and close those computers. Those of you who've got your computers open, close them, please.
Are we going to have computer work?
All right, let's go ahead and go over it real quickly. So you should have discussed it with your table. Let's go and see if you guys were correct or not. For problem number 2, I had a lot of you, I was listening in and you're going, oh no, this is not a scaled copy, so it's false. But the answer is actually true. Here's why. If you look at the question, the question's not asking whether this is a triangle that's a scaled copy. The question says the larger triangle will be a scaled copy of the smaller if the vertical height is changed to 12.5. So they're telling you right now, quiet, they're going to take that vertical height and they're going to change it to 12.5. So this 15, we're going to cross it off. We're going to change it to 12.5. And then we're going to see, does it map up with the 5? And does the 20 map up with the 8? And will the 5 map up with the 2? So we're going to, again, we're going to take our new, this is our new, and we're going to divide it by our old. Write that down for your scale factor. You're doing new divided by old. There are some of you who are talking. You need to stop. So we're going to take 12.5 and we're going to divide it by 5. If we do 12.5 and divide it by 5, we're going to get 2.5 or 5 over 2. Okay, then we're going to take 20 and we're going to divide it by 8. Go ahead. When we do 20 and divide it by 8, we're going to get 2.5. 20 divided by 8 comes out to 2.5. Then when we take 5 and we divide it by 2, it also comes out to 2.5. So the question was not asking if this was a scaled copy. It was asking if you changed the measurement, would it then become a scaled copy? So yes, it is a true statement. Once we changed the vertical height to 12.5, it became a scaled copy with a scale factor of 2.5. Okay? Let's take a look now at problem 4. Taking a look at problem 4. Problem 4 says the green triangle, which this one's the green triangle, the bigger one, is a scaled copy of the blue triangle, and it has a scale factor of 3. So now we're going to check to see first, is it a scaled copy? So I'm going to take 9 and divide it by 6. 9 divided by 6 is going to come out to 3 over 2, or 1.5. Okay, now I'm going to check the next one. I'm going to see if 12 and 8 will map up. I'm going to do 12 and I'm going to divide it by 8. When I do 12 divided by 8, that comes out to 1.5. Okay, then I'm going to do 15 and divide it by 10. 15 divided by 10 comes out to 1.5. So is it a scaled copy? Yeah, it is a scaled copy. What's the scale factor? 1.5. So is this a true statement?
Yes.
Is it a true statement? No. Because look at what the statement asks. It says, is it a scaled copy with a scale factor of 3? Here's the problem. Here's the problem. The scale factor is 1.5, not 3. So this is a false statement because, yes, it is a scaled copy, but they indicated the wrong scale factor. That's why this is a false statement. You have to make sure that when you guys are reading through these problems, you read through them in detail. You need to make sure every part of the problem or every part of the question they're asking is true. Okay, let's go on to the next one, the last question. If the green polygon is a scale copy of the blue polygon, then the missing side lengths will be 4.5 and 18. So they're saying that this will become 4.5. They're saying this value is going to become 18 if it's a true scaled copy. So let's check to see. We're going to check out 4.5 divided by 1.5. When we do 4.5 divided by 1.5, we get 3. Okay, now we're going to check the 18, and we're going to divide it by what? What's 18 going to get divided by, guys? 6. So what's 18 divided by 6? 3. Okay, so far so good. Now we got to check the others. Here we've got 15, and it's going to get divided by what? 5, which equals 3. Okay, still doing pretty good. Still have to check that last one, though. We've got 7.5, and what is it going to get divided by? The 2.5, which equals 3. So is it a scaled copy? Yeah. Okay, those measurements will make this a scaled copy because the scale factor is the same throughout all of them. Okay, so that is a true statement. All right. For the remainder of class time, you can open up your computers and go ahead and get onto Prodigy Game. My 2 new students, please come on up with your computer.